data set for data processing, later linear regression analysis. So we can also use this one for time series analysis because it's purely a time series data. So data include the daily price of 2 years, 2016 and 2017. And totally, we have 731 data points. So in previous assignment, you already visualized the price. So that we can simply work with analyzed data. And I will choose this chart. And to get the visualization of the daily price. So with the time series analysis, we really want to be able to predict. So what can be the price for next day and what can be prices for future week or month. So give some example, let's have a very simple method. So for example, we have the price. So see, we want to predict the price of next day. And what we have is yesterday's price. So we have 15.99. So to predict next day price, and given the last day price of 15.99, and most people will give a number 15.99 because that's information we got. So last day is 15.99, and today is more or less close to 15.99. So that's given the situation, and we only have one data point, and we know it's 15.99, and tomorrow's price will more or less and close to 15.99. So now what if we have a range of observation and say we have observation for those 9 days. So then when people ask you, so what's your prediction for tomorrow's price? And then people will choose two approaches. So some people will base on last day price and will give a number, so 20.75, because they think the price will be more or less close to yesterday's price, so 20.75. And another group of people will see, so the price is not always 20.75. So that will have some lower price and higher price. So in that way, and some people may just to choose the average price. So then instead of 20.75, and some people will see based on historical data, and I would like to predict the price will be close to the average of a historical price, which is 25.33. So that's a certain way, and we can use the historical data and to predict future data. So then one common way, actually, we use it to predict future value is to use the average. But instead of just use all the average, and we like to use something within a timetable. So that we call the moving average. So let me give you an example and to calculate the 7-day moving average. So in Excel, if we want to calculate a moving average, so what we can do is click data and click data analysis and go for moving average. So here we are going to input range. So the data range will be here. So from B1 to B70, 732. And we have label in the fields row. So you need to check this. And interval will be window. We want to calculate based on the historical data. So for 7-day moving average, you input the interval 7. So output range will be, so here I'm going to choose the C2 with a starting point. So now I can click OK to start. So here you can see we are calculate the 7-day moving average. So things day 1 to day 6 and don't have enough historical data for 7 days. So the first value, first prediction on moving average and start on the 7 days. So here we get 26.38. So we can visualize the moving average and to see so how the prediction and close to the historical data. So here we can simply add another chart. So this is the 7-day moving average. So you will see the line actually is close to the historical price or observations. So what if we have a larger window or larger interval? So now let's see how about the 30-day moving average. So you can follow the same approach. So go to data and data analysis, moving average. So we'll have the same data range. So here, interval, we are going to change to 30 days. And output range and will be D2. So we click OK, and and the first prediction and start from the 31. Okay. So first prediction start from the 30 days. So here, let's create another chart and to compare the moving average with the historical data. So this time, since we have a lot in A, so the AI is not good enough to catch what we want. Okay? So if that's the case, I will just select the data range and click insert and choose a line chart. Okay? So this is the 30-day moving average, and probably not so close to each historical price, but the trend is more smooth, right? So based on the type of data we have and certain time, and we can also calculate like 6 days or 90 days moving average, or even yearly moving average if we have the data cover decades. So you can play with these techniques and to create the different average, like 7 days, 30 days, 90 days, essentially. So as I said before, so when you make some predictions, so one way is use the last phase observation of price. And another way is to based on the average of the previous periods, the prices. So what about we balance and use both historical data and also considering the last phase price? And that's technically exponential smoothing used. So exponential smoothing actually balance considering both historical data and also the most recent observation. So you can go to data and click data analysis, and you can find exponential smoothing. So click OK, and you can see here, and you have data range. So similar to calculating the moving average. So here we have our data range. And then they will ask you a damping factor. So in exponential smoothing, you will see in my lecture, so they have a factor as alpha. So alpha actually is a weight put on historical data. And in Excel, the damping factor actually is 1 minus alpha. So if I put less, so that means that the damping factor will be bigger. Say alpha is 0.3, then the damping factor will be 0.7. And the output, I'm going to put here. So this one actually should be 0.3, and you know it's alpha, and damping factor is 0.7. So let's see, we have alpha, right? So we have 0.3 as alpha, and then if we have alpha and 0.3, so the damping factor equal to 1 minus alpha, so which equal to 0.7. So that's why when we use that function in Excel, in data analysis, for 0.3 exponential, and we input 0.7 as the damping factor. So that will be, so we have the 0.3 and times, so for these predictions, and we have times the historical price, and plus, and we have 0.7 times and the previous. Click OK, so that's the 16. So for this prediction, and the calculation will be based on the previous prediction. Right? So we have previous exponential smoothing prediction 1599 over here. and also the most recent observation, and that will be 19.11, right? So given those two data sets, you can use to make prediction and using exponential smoothing. So when you choose 0.3, and basically, and you place 0.3, the weight, so on the historical observation, and then 0.7 and place on, I did it, yeah. So 0.7 and you put on the exponential smoothing predictions. So which then you get this value, 1699 or 1692 as your new prediction. Smoothing or moving average. So actually it's a way I wanted to correct the extreme value and you get and from the recent observation. So this is a good case and to see how the moving average and also how the exponential smoothing works. So see the case and you see based on the historical smoothing or average, and if we use 7-day moving average, we have 28.25, right? So that's a 7-day moving average. And if we use the exponential smoothing, and we have 24.35 as our recent value, and we can use make predictions. So then what happens if our last observation of the real price is $44.58? So there's a certain way you can make your predictions. But given the historical data, and somehow we want to correct this suddenly jump, and you can see it jump from 24 to 44, right? So big price change. And one way you may see it's likely follow the trend. So you will predict, so the price will be close to 44. So because yesterday the price is 44. But another way you may think the market will correct the huge price change and want to back to the value close to the average. So then that's the see when you use the moving average, 7-day moving average. So you want the value correct to 28, so much lower than 44. Right? So if you use exponential smoothing, so similarly, and the price, actually this one, 7-day moving average correct to $32. And use exponential smoothing, and the value will correct to $30 because they put less weight on the yesterday's price and put more weight on your historical or your last exponential smoothing value. And in this case, actually, unfortunately, so the moving average and also the exponential smoothing and didn't perform really well in this case because the market followed the trend. And you can see the next day value actually jumped to even higher, 55. Right? So if you based on the recent price, you may predict 44, and then your error will be about $20. But here, if you based on the moving average, 32, and similarly, if we use exponential smoothing, get the error at $30. Right? So that's the kind of the the bad case using moving average or using exponential smoothing, not the increase accuracy, absolute decrease. But that's an individual case. And to evaluate the value or evaluate the errors. So actually, and you need to calculate the error of your prediction and use all data sets instead of just use one or two data points. So we'll talk about that later and to calculate that error using like a mean absolute value of all of the predictions. So now let's see how about we calculate the exponential smoothing and place higher weight on the recent observation. So here we will put, so for example, for the second day, and giving 0.7, and we will put the higher weight, 0.7 weight on the last day's price, 15.99, and put a smaller weight on the last exponential smoothing value. So click data analysis, exponential smoothing, click OK. And here you see, because we are going to put a higher weight on recent observations, so the damping factor will 22.3. So that is 1 minus 0.7. And the output value we will put on here, F2. So click OK, and the same one will be same because there's no previous exponential smoothing values, and all weight is put on the last price, 15.99. So we got 15.99 for the second day. So for the third day, we have the two references. So we have the last day's value, 19.11, and we also have a previous exponential smoothing value. So for this, we put a 0.7 higher weight on last price, 19.11, and we put a less weight, 0.3 on 15.99. So that's why, and we got 18.17, and that's our third day's exponential smoothing value. And here you can see this is the 7.7 exponential smoothing value. And this is 0.3 exponential smoothing value. So as we increase the weight on the most recent observation, and you can see actually the prediction is the closer to the observations. And next, I want to introduce some technique and you can use and to decompose the data set, the observations, and into chain seasonality and nodes. Okay, so we have this visualization of all the observations. So to create a change in Excel, actually one way we can simply collect data points and click the right button of your mouse, and then you can add a trend line. Right? So when you click add the trend line, and a new window will pop up. And here, actually, we have multiple options. So one way we can add a linear trend line. So when you use linear trend line, you also have options and see forward how many period. So for example, I want to forward 30 days. So that is going to extend the trend line to 30 days. So this is a linear trend line, right? And this linear equation not really makes sense, but basically you can see the coefficient is a point, I think it's 0.072. So that means as the time moving forward 1 day, and they are going to increase the price $0.072. So that's also when we covered in linear regression, so how you interpret the coefficient of the linear regression model. So you can see also provides the future forecasting for 30 days. And we can use a polynomial function or model and to predict future values. And here, you can see we have a polynomial value. So as you know, you can increase the order of your polynomial. The more you increase and the more complicated the model is, and more try to fit in your observations. So here, so in here, you have like x and power of 6 and power of 5. So it can be really hard to interpret this model. But the model do try to fit the data and get more close. So we can also use a moving average. But you can see when you select moving average, and then you don't have the feature to make future predictions because the value just calculate like same thing we use calculate 7-day moving average or 30-day moving average. By default, it's showing 2-day moving average. So that's why it's so close to the observations. And when you increase the value to 7 days, and you can see it's the same to our 7-day moving average calculation, and still close to showing some deviations. And now, as you increase the value to 30 days and later maybe 60 days, and you can see the prediction, the moving average is getting more smooth. Right? So this is also some way, and you can use this trend line visualization and to see. So whether I want to use a shorter window like 7 days or a little bit longer window like 30 days, and to make my predictions. So the seasonality, if we have a window or the seasonal window 30 days, and we will have this figure, this value. So in here, and as our seasonality, so 30 days. So it's kind of monthly, repeat and certain similar pattern. So our data, and it's not really consistent with the 30-day moving average. But more or less, and you can see some pattern repeat at the monthly window. And if you think about the linear trend, right? So the data will be value 1, 2, 3, 4. So that is a sequence of your observation. So what you can do is utilize the linear regression and to do the calculation. So here I can go to data and I can click data analysis, and I'm going to use a regression. And the input, the Y, and will be the price. Okay, so that will be the price. And the X and will be the date. So that is a linear prediction. So you have the label, and then I will choose the residues, the predictions. So I click OK with this chart. You also can see it's the linear trend line, right? So here I'm going to just copy paste those predictions, and then I will paste it here. So the predict price based on the linear regression model. So to calculate the noise for each observation, and I will remove the value from the prediction chain. Right? I will also remove how seasonality value repeated at the monthly base. So others will be your noise. Let me modify the trend line. So I can double click and then select linear. So I'm going to have linear trend line. So here is how you can present this data and also create the time series decomposition. So what is showing on this screen, and you have your observations of the historical energy price. And then this dot line is showing the order change, 2016, 2017. This one showing some seasonal pattern, and on the monthly base, this is noise value. And that is something we cannot predict. So one way we can evaluate prediction, it can be very straightforward. You use ABS, so the 7-day prediction. So the value minus the historical price. Absolute error. You can create the mean absolute error. The mean average error can be simply calculate the average at the bottom. So we calculate the mean absolute error. So now you can see the error is around $4. So previously when I show when there's a big price change, and sometimes the moving average or exponential smoothing not produce like better predictions. And so if you use just the last day's price, your error is 10. But when you use moving average exponential smoothing, you got error 30. Right? So you will see, oh, that may be not the case. Use moving average. But if we use it all time and basically over on this 2 years range, and your error actually is smaller. So here you see it's around $4. So you can calculate 30-day moving average, 0.3 exponential smoothing, and 0.7 smoothing, and also the prediction from linear regression. And you can see which one actually produced better the mean absolute error. This actually is not MAE, it would be named as AE, the absolute error. So that is the absolute value of the difference. And this one should be MAE.